All right. So the goal today is, you both do a ton of computer drafting, but as things get more complex, it is well worth your time to draft it by hand first, work out the kinks with a pencil, and then draft as opposed to, making a box and then making like 500 steps to fix that box into whatever shape you want in CAD. Just like start with the right shape. So let me.
Do I have enough light here? Let me light here. And does that make it worse?
No, that's good.
Okay. Okay.
So, this is just done by hand with no tools, and I think eventually you guys will get to the point of no tools, but it's easier, I think, to teach the principles with just, one triangle and a T-square. See if I can rotate this like that and get all this aligned. So this was like a mount that I drew for a laser shutter timer tester module that I'm building. But we're going to start today with orthographic, which is like a straight-on view. So today, let's say we're drawing this camera that I made yesterday, right? So like the orthographic views are the straight-on flat to the face views for the most part, where like they can get it straight. That would be one view, and that would be another view, and then that would be another view, and then you have the top view. And we can relate all of those views to each other using guidelines so that all of the measurements match up. And then we're going to use those to create an isometric view, which you guys are very familiar with from CAD, which is like, kind of if you take this view and you rotate it 45 degrees like this, and then you rotate it 45 degrees like this, you get, these lines here, here, and here form a 120-degree angle, projected onto this plane that your camera sensor or paper is. And the 120-degree separation of this line and this line and this line is like a really important thing that has a lot to do with your 30, 60, 90 triangle. You guys with me?
Yeah.
Okay.
Yeah.
So let's start by just drawing a cube. Eventually, I'll show you where we're going. I made kind of like, let's see, cut that down a little.
Yeah.
So, this is just like a standard practice object where you have the top view, the side view, or the front view and the side view, and they all relate to each other. And then this isometric is actually not to scale, but we'll do a scale isometric. But let's start with the cube. So, crank my tripod up again. I'm going to do this with a real thick pencil today. I would usually use like a 0.5, but I'm going to use a 0.9 just so you can see it on the webcam a little bit better. So let's talk about these tools for a second. The T-square allows you to make, and I mean, okay, so if you're a professional, you have a drafting table and either a T-square or like a, I don't know, it's maybe called a line or something, where you have one edge that always makes horizontal lines. And from there, you can make, just with a 30, 60, 90, you can make vertical lines up and down, or, horizontal lines. You can also swap your T-square like this, right, and make horizontal lines here. Likewise,
Okay.
and this is going to get really important, is you can make parallel 30-degree lines this way, and then you can flip the triangle over and make them this way. And that's basically you're just going to use like this corner of the tripod or the triangle to make everything. And again, like you're going to learn it with the triangle, and then you're going to be able to freehand it to make things like, this is a freehand sketch of how a circuit board fits into the box that it sits in, or
do we have to do all that writing as well?
No, this is another good example of like why I draw by hand first is figuring out how all of these laser cut pieces to the front standard of a camera go together. Like you can just doodle it. And this I didn't use any tools to do, but I used the same principles of, 30-degree parallel lines while looking at a square object from 45 degrees rotated one direction, 45 in another. And so we'll start with the cube, then we'll add a complication to the cube, and then we'll do, orthographics, isometrics, and then exploded isometrics. So we can draw, you probably do this in CAD too, is like just pull the pieces apart and look at them from an angle, which is useful for assembly diagrams and sort of seeing how things go together. So I'm going to start and just draw, let's say, I'm going to freehand this one. I'm going to do a cube that's, let's say, 3 by 2 by 1. That's not to scale at all. I'll take those numbers afterwards. So first we're going to draw an orthographic view of this face. So this is not one here, sorry. This is one. You with me so far?
Yeah, less confusing. Yes.
You can put these lines in here. Okay. So first we're going to draw this face as an orthographic view. So I'm going to choose centimeters as my units and make a little mark here. 1, 2, 3. A little mark there, and draw straight lines. There. And an eraser is helpful. So that's my first 3 centimeter line. Then I'm going to make a 1 centimeter line here. So this, use my triangle and T-square, 1 centimeter. That.
Oh, hang on a second. Okay.
That. And I can come across the top with the T-square, and so that's the front view.
Okay.
Mark these here. Front. Side. So an interesting thing is that all of these views will have matching dimensions, at least in one dimension. So this side that's 2 units deep and 1 unit tall is the same height as this 3 unit wide and 1 unit tall. It's got the same height. So I'm just going to do it with a lighter line, or often I'll do a couple. So this is a 0.9 millimeter pencil. It's very thick. This is a 0.3 millimeter pencil. There's also like different lead hardnesses you can use. You just do this with 1 pencil and just press less when you make a guideline. But what I'm going to do is use, for now, just to show you, this is a 4H. So it's like a very hard, light pencil that's also 0.3 millimeters. So we'll see if it shows up on camera, but generally this is what I would use to make guidelines. So I'll just follow the top here I don't know if you can even see that line. Follow the bottom. And now I have a dimension for the height to make sure that they're matching without having to measure. And also they're going to be on the same plane or the same, same altitude.
So how far along did you just go there?
I just went to the edge of the page. These are very light lines, so if you're just making a sketch for yourself, I might leave them. If you were a professional draftsman, eventually you would go back, erase the light lines, and then make them with a heavier pencil. But I'm going to leave them in my drawing just so we can see how it was constructed. So let's see if I can see your screens in my phone. Okay.
I've got the lines. They're pretty close to the same. I did switch my pencil to that bigger pencil, but the line's not the same. I wasn't making a huge difference in lines.
So, Graham, you don't really have something to hook your T-square onto. So what I would do is I would put the T-square on the edge of the table like this, and then draw my horizontal lines with a triangle.
Okay.
So that really what's important about using the tools is that it allows you to make angled lines that are all perfectly parallel, so that measurements line up between pieces.
Okay, gotcha.
Yeah.
Gotcha. Okay, so that worked. That worked quite well.
Okay.
Okay. Yep.
Gotcha. You got it.
Yep. Oh.
Okay, so we've got our front face and then the guideline.
Mm-hmm.
Okay, so the next thing we're going to do is draw this side face. You could do it any arbitrary distance away. Just going to pick it here. I don't now need to measure, 1 unit tall because I have these guidelines. So I can just go from here to here with my T-square. And again, I'm making this side, right? Then I do need to measure this 2 units, which will be 1, 2 units. I'll draw my second side, which is so I'm now drawing this line here. And then I'll do the top and bottom. These would be much more crisp with like a nice laser cut T-square and an actual drafting table instead of relying on my book to be square, but okay. So make a side view. Now, one interesting thing is we can, again, translate the front view up to create the top, but we can also, and for a cube like this, I would probably not bother to translate the dimensions off the side. I would just measure. But just for the purposes of learning how this goes, what I want to do is create a translation of these dimensions, this 2 unit side, over to the top, which will be here, right? And so how do you reflect this 2 units from a plane over, horizontally to a vertical plane? If you reflect around a 45-degree line, then you get horizontal to vertical translation. So I'm going to draw this guideline. It doesn't need to be anywhere in particular.
You're on a 45-degree triangle there?
Yeah. And actually, so I'm going to start making these guidelines a little thicker. I'm going to use a thick pencil just so we can see. You can make them nice and light on yours. You certainly will in your future drawings, but for the purpose of, what are we doing? Webcams. This is my reflection line.
Okay. Yeah, I'm trying to figure out how to do. There we go. That's what we're doing. Okay. There we go. I just have to use 3 rulers to translate up to it since I'm coming on them.
Do you guys have your 45-degree triangles?
Yeah. Not yet.
Okay.
I will. In 15 minutes, I will.
Okay, so you might not draw that reflection line just yet because you really need a perfect 45.
I can do 45 with this. Protractor thing.
Okay. Let's see. What are you using there? Unpin myself. Oh, yeah. That's 45. That's way better than the ones that I printed. I mailed Graham some nice plastic rulers, but I wasn't going to mail them to you in England, which is why I made these 3D printed ones.
Yeah, mine are Stedler. So,
ooh,
yeah,
I ordered that for myself too. I think they were $3, but they will get here like Sunday. I don't know. Okay, so now what I want to do is first just translate up. Hang on a sec. I want to translate up the width of the front here because this line is 3. So I'm going to do it with a thicker pencil. I'm just going to make thick guidelines for now. Follow that up with the vertical line and then
the other side.
Yeah.
Guys, I'm going to mute for a moment.
Sure. I'm going to make my exposure a little less. You can see my guidelines. All right. Can you see my guidelines, Simon?
Yeah, they're fine.
Okay, great. So the next thing I want to do is actually translate this width, which is here, to this plane over here. So I'm going to run the guidelines up to the reflection line first.
Sorry, guys. I am back.
Oh, yeah.
Okay, so we're on that side. Okay.
So, yeah, what I'm doing now is I'm taking this 2-unit dimension here, and I'm bringing it basically over here. So first thing I did is I drew this guideline and this guideline up to the reflection line. And then I can translate them over from the reflection line.
Okay, I don't know what the measurement was there that you have up from our side view. You've just...
So it doesn't matter.
It's just where they connect.
Right. It's wherever it hits this 45 degree. And you could be precise about spacing these guys and where you put the reflection line. For now, we're not going to worry about that. This line, so long as it is 45 degrees to this line here, it's always going to reflect this guy. And it'll affect, where you put the line and where you put the side view will affect where this top view happens, but it doesn't affect the dimensions and the shape of the top view. So now I have the side dimensions from the front and the side dimensions from the side, and now I don't have to measure anything. I can just trace. I have bottom of my T-square is a little bit straighter. Not professional tools.
What are those?
Yeah. Okay. And then I can come in with a triangle and make the vertical lines here.
Yep.
All right, so now we have a top. Mine look a little wonky, but that's okay.
Okay.
Okay, so I'm having a hard time seeing both of your drawings, but are you guys with me that you've got front, side, and top?
Yeah.
Okay.
I do.
So
I'm sorry.
I mean, this drawing is really, so simple that you would not need to draw it, but it illustrates the principle of using a reflection line and using guidelines and the tools to make corresponding front, side, and top views, which we will need then to make an isometric view, which is this thing, but, a little bit nicer. So, let's start making an isometric. I'm just going to put it over here. You can put it anywhere. Traditionally, you'd put the isometric drawing here, or erase all this later, but whatever. So the front. So let me think about how to say this. All of these 90-degree angles are going to be translated into either 60-degree angles or what is this, 120-degree angles, because you're skewing it as if you were looking at it, kind of that corner on. So I'm going to start by drawing the front face. Right? So we have a 3 by 1 inch or centimeter front face. And so I'll just start.
And we can draw this anywhere, right? We're going to draw this anywhere. It doesn't relate to the lines that we've already.
Correct.
Okay.
So I'm going to just start by laying down a guideline, which is the bottom. This guideline is this surface of the cube. So
so we're doing the hypotenuse on the right triangle.
Correct. And facing this way. And you can make it face the other way, but I'll just keep it oriented the same way that we have it. And so the measurement is 3.
Oh, I'm gonna have to make a measurement on that. I don't have a measurement doing that direction. Okay, figure it out.
2, 3.
And second.
So that's a 60 degrees, is it? Yeah.
Yeah.
Okay.
Sorry, if Simon, just use the triangle, right? So you have a T-square and a triangle.
I've only got the right angle at the moment. The right angle triangle. Yeah.
Okay. I'm going to have to make the line and then measure along the line because I don't have a measurement on that side of this one. So
Simon, this is actually 30 degrees off of 90. Right. So if you have a horizontal ruler, this angle in here is 30 degrees.
Okay.
So
is that a 45-45 or a 30-60-90? That's a 30-60-90. Yeah.
Okay.
That'll do.
Okay. And then 3 centimeters along that puppy. Okay.
It's the wrong way round. It's the wrong way round to get the measurements on it.
Simon, the way I would do it is just use it the right way around to lay down a guideline, and then you can use any sort of ruler to measure the 2 points, then put the triangle back and darken that line, right? So it's nice to have this whole long guideline here, just to give us a reference point.
And that's 3 centimeters, yeah.
Yep.
Yeah. Okay.
So the interesting thing about this is a lot of product designers will use 2 or 3 point perspective when showing an object. And in a way, an isometric view, isometric means same meter, right? Same distance. It is a 3 point perspective if you were infinitely far away with an infinitely long zoom lens. I know, Simon, you've had some arguments over this.
Let's not go there.
Right. But that, the idea is if I were to look at this box, very close up, let's get it in the camera. This portion of the box over here is a little bit bigger than these portions, and so things recede and parallel lines are not parallel. Like when you take a picture of a building that's you're looking up, right? The building keystones, right? So then you start bending your camera to fix things. But the idea is, to make, like in product photography or architectural photography, it's often when you can, beneficial to back up and use a long lens. That way, the proportional distance of this side of the cube to the lens versus this side of the cube to the lens is very small, and so this line and this line approach the same length as do this line and this line, right? So we're drawing that perspective, which is used by sort of engineers and machinists way more often, whereas point perspective, as you might see something in real life, is more used for like product design and people worry more about aesthetics. But right now we're going to worry about isometric and engineering drawings. Okay, so you've both got this line. So the next thing is the height is 1 unit, and so I can bring my T-square and ruler here, and I can make a 1 unit line vertically.
We're getting focus on your hair.
Oh, sorry. What's left of it? Old spot. Okay. So I'm going to make 1 unit.
Guideline and measure.
Yep.
Okay.
And then I can come in and draw the top face with my triangle.
Hang on 1 second. Let me. Okay. Oh, I see. Okay, so just moving that other one up.
Mm-hmm.
I said distance.
And so you could measure and draw a 1 centimeter line here and a 1 centimeter line here, and then just connect them with any sort of straight edge freehand like this. But I find that does not lead to good parallelnicity. My ability to measure, particularly when I'm working in centimeters instead of a larger drawing, is poor. But if I just take one of those measurements and I use this triangle to draw a parallel line, even if, I don't know if you can see here, I overshot just a tiny bit on this side, I still have parallel lines on top and bottom and on the sides.
Right. And what about your Englishnicity?
I don't know. Simon has the Englishnicity.
It's fine by me.
Okay. Simon looks like he's got it. Graham, you've got it. Okay. So the next thing I'm going to do is I'm going to draw the side here, but I'm going to draw these same guidelines to draw the side, except now they're not horizontal, right? They're up at a 30-degree angle from the horizontal. So I take my triangle, and without measuring, I'm just going to draw these to the edge of the page. The guideline here, again, much darker than I normally would. Really, you want to use like a very fine pencil and as hard a lead as you can for guidelines so that, they're easy to remove later, but we want to make sure how this is constructed. And then I can also throw a guideline on this corner. This corner here is going to be this corner, right, which is going to work out like that. So, all right. So now you should do something like that, which is sort of like an infinite extrusion of this box. And now, so we know the side is 2. There's no guideline to be thrown there, so we need to measure.
Sorry, I've my tools have just cooked. They've come out the oven. So I've got them now.
Oh, great.
But,
I mean, it looks like the tools that you've, awesome.
Okay.
think those are Cameradactyl official.
Yeah, they are.
Actually,
you find them on GitHub for free.
Yeah, I thought. I mean, these are both right angle ones, so I still haven't.
No, you have. So, Simon, they're both right angles in the corner, right?
Yeah.
But one is 90, 45,
I get it.
45, and the other is 90, 60, 30.
Get it.
So that 45-degree triangle, really today, I just used it for making this this reflection line here. It does not come into play often. It's not for what we're doing, we really don't even need it. However, if you're in a notebook and you don't want to use like a T-square hooked over the side, often if you take this guy and stick it in the spine, right, then you can use the two triangles together and use the 45 as a T-square and the 30, 60, 90 as, you know, your guided triangle. Okay, so we've thrown these guidelines out from the corners. Now we need to measure this distance on this side here, which is going to become this distance over here. So this we know is 2. Throw in my here. Oh. Okay. I know this goes like that. And then I can throw from the end of that 2 centimeter line, I know I have this vertical line here or this here.
Oh, there we go. Sorry.
And then I don't need to measure this 2 centimeter line because I know where the guideline is and I know where it intersects the vertical line. And so I can just bring the triangle back and draw this guy. So now I have the side face of the box.
Hang on a second. 1 minute. Oh boy, I gotta bring it to the other side.
Yeah. So on a drafting table, this is much easier. Like this little bit of this T-square is a little wonky, and so I like to use this side as a straight edge. But you know, some professional tools would help. But ultimately, like where I want to go with this is not to make you guys draft with tools. I just want you to be able to do it freehand before you have to work things out in CAD. Okay, so now we have this corner here and this corner, which should totally define the top without measuring, right? So I need a guideline that goes this way to define this corner here. So I'm going to take my triangle this direction. I can draw the back of the top face. And then I have this back guy defined here. Done. So now I have front. Let's see. Side. And all right, when you guys are ready, I want to say a word about shading. It looks like you both are. So often we use shading as if we're trying to match light, but in mechanical drawings, we use it less. I mean, you could imagine a light source, but I'm just going to do even shading for the purpose of showing which faces are facing which direction, right? And so I would never shade the top, front, and side orthographic views because they would all just be one even shading. There's no purpose, right? But I'm going to imagine like a light source somewhere like here behind it, right? So this side and this side will be shaded. The top will not be shaded. And then I'm going to arbitrarily pick, you know, the front is going to be the darkest and the side is going to be a middle tone. And so if you have 3 tones, you can always make each plane of the surface stand out. And that's not really important here, but like, you know, as your things get more complicated, let's see if I can find one. Go back to this sketch, right? It really helps to use shading to show sort of like in this drawing here, for example, you know, there's just a lot of parallel lines, but shading shows the shape of it. So I'm going to make this one pretty dark, bunch of parallel lines. And you could do this with your ruler or T-square or triangle, but I think by hand is fine for our purposes. And then I'll do this side less so. That's a pretty bad job of shading, but I think it, you know, for technical drawing, it's just fine. Great. Okay, so now we've made a square. Let's try something a little bit more complex, and then we'll go to exploded isometrics, and that's basically it. I'll say a word on circles eventually, but let's forget about circles for now. I didn't want to get compasses involved. So,
do I need a new sheet of paper, or are we going to have enough room on this one?
Might as well switch to a new sheet of paper.
Yeah, okay.
So I think what we'll do next is draw this shape. So, you know, it's basically a box with a angled section and a cutout here. So let's see.
Okay. I'm ready.
Okay, so I'm just going to draw one by hand in the top corner of what we're drawing, and I'll dimension it. And then I'm going to kind of let you guys go, which maybe, you know, if we make a video out of this, I will just fast forward and then we'll talk about it at the end, because this is just like a practice thing. We'll see where you run into problems. So let's make this 4, this 4, and then make this guy 2 in here. And I'll make this guy 2, keep it pretty simple. And then this can be 3. So this is going to look a little bit different because I've dimensioned it, you know, differently. Make this 2 here to here. And then I'll make this
4. What's the height? 3? And okay, the cutout. How high is the cutout? Or why don't you bring that up a little closer? There we go. So I'm doing my own little version of that. So that's a 2. What's the top width?
So the top width should be defined by this width and then this width. You subtract the 2, you have the width here, which is...
Oh, gotcha. So it's 2 and 2 and... Okay, and that's 1.
Often the style of technical drawings is they will not dimension any more than is necessary to calculate, just to keep the number of you know, dimension marks low.
Okay. Gonna go ahead and start.
Okay. Simon, you ready?
Okay.
I must admit, I thought you were going to leave that on the screen there, so I'd need to do a quick drawing of that. So that's 3 down, and it's 4 across, and then up by 2, yeah, and then in by 2, and then this way it all goes strange now, isn't it?
Yeah.
Yeah. Okay. So that goes there. That goes up there. Oh, I've already gone wrong.
Okay.
That goes up there. Oh dear, this is. That's going awful. That is. I know I've done that. I've realised I should have done it 60-degree angles. So let's put that there. That's 3, and then.
So, like in school, they usually do this the other way around, where they give you the 3 orthographic views, and then you have to draw what the isometric looks like from it, which is much trickier sometimes. But I think drawing the isometrics is important too. I need a better rostrum setup. There we go.
And number 2. And then.
So 1, 4.
Okay, that's all I need for this one.
So that dimension from there to there is 2. Is that correct?
Hang on, I can't see your screen. 1 second.
Yeah.
Oh, and I've got a diagonal.
Okay, hold on. Let me pin you so I can see. 1 second, Simon. Okay, which dimension?
That one.
That one is 2, correct.
Yeah. Okay. I think I've got all the ones I need.
Okay, cool. So let's just take 5 minutes and draw the isometrics with the reflection line, and then draw the orthographic, and let me know when you're done. I'm going to do one over here, but, not talk about it.
What I love is that you've got the optimism of 5 minutes.
Oh, yeah.
Okay. Sorry, I have to schedule my Dungeons and Dragons. So.
Really?
Yep.
So was the height of it 3?
Yes.
Yeah. Okay, that's fine. Yeah, that's fine.
Okay. Okay. And that with side view. Okay, that view. Okay.
You can also use guidelines within a piece to help you align things.
Yeah.
The bits I'm not 100% sure about is what's going on with the slope at the back and how that's drawn.
Right. So that basically what I'm going to do is I'm going to draw a point to here and a point to here, like these guys. And then, if I was being a professional, I would have like a protractor or like a, variable angle triangle. But this slope, I'm just going to freehand from point to point so that it matches like that.
Yeah. So you're not putting the cutaway then, because you've got a 90-degree angle in that, or you're drawing them both.
Yeah, I will draw them both.
Yeah,
right.
Yeah, that's fine.
Oh, okay. For a second there, I thought I had made it all too tall, but I did not. So I need, okay, I am missing, no, never mind.
I think I've drawn.
Missing, but, oh, sorry, Simon, go ahead.
I'm just wondering if I've drawn my side elevation too close to the other one, unless I've done my sorry, I've done my 45-degree line off the wrong section. Yeah, I get it now.
So, Simon, I would recommend, if you're using that protractor for a line, that's pretty good. If you swap to the triangle, there will be no variance between two lines that you draw. Like, that line is fine. Keep going with it. But try just using triangles and no protractors.
Yeah.
It is more...
I'd forgotten I've got the that this has come off now, so
yeah.
Yeah. We've got new technology to work with now.
It's way worse technology, to be fair, but
God, that top is boring.
What's boring?
No, I'm sorry. It just starts out as a square, right?
Yeah. Yeah.
Okay. And tomorrow we're gonna kill goblins. That's what we're gonna do. Okay. That's right. And then there we go. Boy, drawing off previous drawing, it's almost like tracing.
Yes, exactly. So the difference is I think artistic drawing and technical drawing can both be taught, but artistic drawing you teach and then you spend years learning to actually do. Whereas technical drawing you teach, and like, yes, there are aspects of like how you hold your pencil, like things that I am definitely not good at in terms of making crisp lines, but basically you just use the tools to make everything. And so it does not take years of practice and seeing. It just takes a bunch of rules, and you can make pretty perfect drawings every time. That's what I love about it.
Oh, I didn't do that.
No, I didn't do that either.
Do what?
No, I'm sorry. I just realized that I didn't follow the second to the third there. Sorry. I wasn't paying attention. I just, yeah. Okay. Anyway, doesn't matter. Okay. So let's see what we got to do first. We got to get that line. Okay. And I need to be, that's going to be my start. Yep. Oh. Oddly enough, if you don't advance the lead,
Yes.
so does nasty things to your paper.
Yes.
Okay. So then I need and
That's not going to fit. This one.
okay.
Also not going to fit. Working in a tiny notebook, I keep making everything is going to intersect here. I think I can get it.
Oh.
That goes up 2. No, that goes up 1. Okay. We've got 2 down here.
The first level is it 2 centimeters high?
It's 1 centimeter high.
Okay.
I drew it not to scale.
Yeah.
First
So
time.
the second part of it is 2 centimeters high.
Correct. Top
Right.
level is 2, bottom level is 1.
Right, get you. Oh, I'm making a horrible mess.
That's the fun part.
Oh, this is awful. Okay. I think I'm going to start this one again. This is just way out.
I laugh because I think that I'm going to probably be doing the same thing. But so far, it is so good on mine.
I mean, I throw a lot of drawings away, to be fair.
And that's 4 along there. These dang inches keep begging me to measure via inches. We have to slay the Imperial Dragon.
See, that's one of the better things about being British, is that you can go whichever one works best for you, and you have no problem with it.
But how inches would work best for anyone, I have no idea.
Well, they're fine as long as you don't break them down more than a half. You go past that, then I move into centimeters.
Yeah, right, exactly. So one of the things that I see a lot on, that's not a line. One of the things that I see a lot on I don't know, on sales items, you'll see 12.7 inches, 12.7 feet. They'll take the number and then they'll decimalize it, even though yeah. So I was just watching an episode of Inspector Morse, and
what?
Inspector Morse. Haven't you ever seen Morse?
Okay,
it's a British series. The main character is always falling in love with one of the
Graham cut out. He'll be back.
Yeah. I know of the series. I know of Inspector Morse, but I've never. Well, I think I watched the very, very first one. I didn't like it that much, so I never watched it again.
The secretary was going to see a band called Metric Conversion, which is probably the best name for an 80s band ever. I'm just embarrassed that I had never come up with the name Metric Conversion for my band. That was a hell of a great name.
Just a quick one. The slope, is that 1 centimeter wide? The slope.
This slope here.
You haven't got a picture anymore.
My camera's died. Let's see. Give me 1 second. Yeah. Show me the slope.
It's the ski jump. But
right. So that's 2 centimeters wide, right? The cutout is 2 centimeters.
All right. So it's yeah, that's fine.
Okay, I'm done.
Battery.
Hey, Mr. Ethan, check my work. Mr. Moses, check my work. Check my work.
Busy breaking my camera here. You beat me to it.
Okay. Can you see mine?
Hold on.
Okay.
I'm fiddling with my webcam.
Speaking of Morse, where you'll see it is if you follow Nasser Hamid on Instagram or Flickr or wherever. He takes shots around Oxford, and they shoot a prequel series there called Endeavor, and he takes a lot of shots where they're shooting Endeavor. So, Mr. Moses.
Yes.
Is that
Let's
right?
see.
Do I need to focus or anything?
Yeah, I'm having a hard time.
Okay.
Yeah.
Okay. Here, turn it right side up. And here, I'm going to pin myself so I can. There we go.
Yeah, that looks great.
Okay.
Exactly. And so here, just try giving it some shading.
Yeah.
I think it, as the object becomes more complex, right? The shading becomes more important to actually reading the object.
Right. Okay. Okay. So here, let me. And by the way, Simon, I'm using a hashtag best vintage lens right now.
Oh yeah.
This is a Canon EFS 18 to 55 kit lens.
Yes. That pretty much that fails on all of those things except the word lens.
It was, I needed, my 35 millimeter was just too long for this webcam. So I started looking for this, for the 18 to 55 to use, so I could use the 18 end of it. And I never use autofocus on these things. So I just looked for one that was broken and got it for $20 shipped. So you gotta love that. That is certainly best vintage.
In 2010, 10 years ago, I had 2 Canon XTIs with 2 of those lenses that I used backpack strap to sync the zoom, and so I had a zoom stereo camera, just like around.
Nice.
Yeah, that was pre 3D printing for me, so I had to I spent $200 or $300 having custom milled aluminum brackets made by Berazin Photo Optical. This is a nice camera. A lot of weird stuff with it.
I the XTI, that was my first serious digital, and then I had a 40 or 40D. I can never remember whether who has the in front and who has the left behind. I had a 40D, and then I bought an XI, a T3i, and converted it to full spectrum. So that's kind of nice. It is. There's my deal. Boy, looking at this upside down, it really did not become a shape. So Simon, as I was saying, I am in the process of building a 4x10. I'm building it around the negative holders that I got. So when I've got that done, you got to have me on large format.
Yeah, that could be arranged. That'll probably piss Nick off as well, won't it? Because I think he's angling to get on to that one as well.
Oh yeah.
The most popular podcast.
Yeah, there we go. By the way, Clyde Butcher. Oh, go ahead.
I was just going to say the download figures for the large format are catching up with classic lenses at the moment.
Wow. Yeah. The Clyde Butcher. Okay, so I teach at a community college, small school. Well, they used to call them community colleges. Now they call them state colleges for no reason at all. But our community college owns an art gallery that is of the quality of a. It's off campus, and it was started by somebody, and they donated it to the school. It is of the quality of a city, maybe 5 times the city size that's in it, which is in the city of Ocala. And we had Clyde Butcher there in, I think, I had arranged to go see him, and it was essentially a book signing as opposed to a show or a talk or anything like that. So it was a little bit less attractive to go to, but something happened, and I don't remember what it was, and I just couldn't go. And I thought, oh, to see him next time. I mean, just seriously, superhero. Although the black and white versus color, old man, get off my lawn kind of thing, is a little bit much. But I loved listening to him.
Yeah, it was great fun. People had been spitting their drinks out when he started to have a go at people that would shoot slide film, like Ben Horn, and and then just say his photos were flat.
Right. Exactly.
Oh dear.
I always kind of go back and forth. Do you have the right after a certain time to be that old man who is saying "get on my lawn," or is it just
never cool?
Or is it it just is invalid? So yeah, I don't know. I think his work speaks for itself. But yeah, I know.
Yeah, I think it's one of those things when you've done something and you're so respected for what you do, then and also when you're 79, you've got to. I think that's the thing. It's that thing when you look back at, not judging previous generations by your own generation standard or what was going on 100 years ago or something like that, and but that in itself is extremely problematic as we can see at this moment with all the things that are going on with slavery and so on.
Right.
So it's a tough one. It's a tough one, but you got to, if you're pragmatic about it. I mean, there are things there I would say something to my father, and because he would come out with something that is just completely out of tune with today's society, and he's saying it with all good thoughts and good meanings, but it's just wrong, and it's wrong, and it's a case of you can try to educate why it's wrong, but you get to a certain point where it's very, very difficult to do that, or nigh on impossible, because you can have the conversation, it can be acknowledged, and then it's forgotten about in the next, almost as quickly as you've said it.
Right.
So,
right. And part of the deal is it's very hard for people to hear that the way that they've been taught to think is wrong.
Yes.
And but that's how we grow, we challenge the things that we used to think was right. Like there are no good zoom lenses.
Well, there aren't. So that's
My thing with zoom lenses is I don't have any problem with the image quality, because
I'll be right back.
Image quality is image quality, right? It's image quality is overshadowed by what you're pointing at. At least that's my opinion. But my problem with zoom lenses is like this 18 to 55. When I actually had one of these and used it, it was either at 18 or it was at 55. So it was essentially a dual lens setup with none of the advantages. Well, it has the advantage that you're not swapping out a lens in the field. And that's the one advantage. But then you pay the penalty in speed. So anyway.
I mean that's usually the biggest criticism of zoom lenses anyway, that they're you do use them at the extremes, and if that's all you're doing it for, and all of your photographs are at the extremes, then a prime or two prime lenses will almost undoubtedly give you a better image, potentially anyway.
Right. Yeah. Absolutely. Hey, I have a question about one of your co-hosts. Is Perry independently wealthy, or what the hell is his stock? I could retire on his stock of equipment.
Yeah, he used to be involved in finance, and then he got out of that because he absolutely hated it. Loads of moral conflicts going on, and so he became a teacher. But he teaches. I think he teaches English as a doesn't do that. He does debate, teaching debating. So the kids that he's teaching are probably high wealth, high value people, if you like, and one of the conversation. I mean, this isn't going to go out anyway, is it? But all that conversation about Clyde, for that matter, and that's he was charging a certain rate, and he was very busy, and he decided, you know what, I'm too busy. I'm going to just charge more, lose a few customers, and have a better quality of life. So he literally doubled his prices, and now he's busier than he's ever been.
Oh yeah, that is in the fine art world. I've been teaching in art schools for a long time, and I know a lot of people who do. Hang on a second, my wife is calling. Yes, ma'am.
I increased the prices of the larger thing, Cameradactyl, because it's been really hard and expensive to get filament during COVID, and it has not slowed anything.
No.
Right. Yep.
It's just worth noting. I've probably only got about 15 minutes left before I have to go to the post office.
Okay. Simon, it looks like you did it perfectly. Okay, so I'm going to give you guys another challenge, which I drew here. One thing that I didn't cover is lines that are not on the surface, right? So this is the cutout, and it's a 1 by 1 centimeter cutout, right? Here you see it. You see this line across the top, right? That's this line here, but this cutout line it's dotted where it's not on the surface, right? So if you're looking from the top, there's no cutout, right? You wouldn't see it, but you can see through the object with the dotted line here and here. So to mention this is 1. This is 2. I think that is enough dimensions that you guys could draw this one. Zoom a little.
Okay. Okay.
So the trick is going to be reproducing first the orthographic, right? So you have a reference, but then from this, reconstructing the isometric view without seeing what the object looks like.
Okay. Okay. So here, let me do a quick sketch of what you had. Well, you just leave that up, and we'll and I'll run off from that. Simon, one of the things that Clyde mentioned a guy named Jerry Uelsman. Did you ever get a chance to look him up?
No.
Okay. He is okay, so there are two big Florida photographers. One of them, of course, is Clyde. And the other one is this guy named Jerry Uelsman. And what Jerry Uelsman did was he did fantasy Photoshop stuff. And what I mean is he would blend a photograph of a tree and a photograph of a house. And so the tree or the house would look like it was growing directly out of the tree. That's kind of his big, famous picture. So I was, as I said, I was going to be talking at my school, and I was trying to get some of my neighbors to go with me to the show, and all that was arranged and then fell through. But essentially what I said to them was, so who, if I say Florida photographer, who's the Florida photographer? And they said, Jerry Uelsman. So he's the guy from Florida who's like super popular. And he's worth a look because he did all this stuff in camera in the 80s and 90s that anybody today can do in Photoshop, and is but it's, you know, obviously it's done.
Way more impressive back then.
We'll say it again.
Way more impressive back then,
Right?
Like if we were in the 1800s, just taking a picture in itself would be impressive. Now we got those smartphones. It's amazing. You know, I really like drafting. You know, I really learned a lot, and it changed my life. What Ms. Gould taught us, and it took like 6 months, and you had to go to school and like sit in front of a table for whatever period in high school that was. But you know, like now we can just like do this over video chat, or even better, you could watch a real draftsman on YouTube.
Mm-hmm. Right. That reminds me of you know, the one class that probably best prepared me for life in high school. It was typing.
Uh-huh.
Now, because that has now allowed me, well, hell, you know, all the different jobs, all the different, you know, everything.
Yeah. Hey, Graham, why are you using that terrible pencil?
Oh, just simply because I picked up the wrong one.
So, the deal is like this metal sleeve here allows you to follow a ruler really crisply.
Right.
It also allows you to push really hard on the lead without breaking it, which would help me to see what it is you're drawing.
Oh, okay. Yeah. So Here
Oh
we
yeah,
go.
Simon did it. Cool.
Okay. Wow. I need to figure out my 45. Oh, it doesn't matter where my. Oh, 45. I have the wrong ruler.
So I just looked up and I was just wondering, is Graham on the next one now?
No.
he's bound to be ahead of me.
Yeah. There we go. And oops. Okay. Oh, hey. I don't have a reference. I miss. Oh, wait, no. I need a reference, do I? Oh, I don't know what's Yeah, okay. I gotcha. Oh, that thing didn't hit straight. Okay. And yeah. Oh, that dash. Crap.
I think there might be a thing missing from Simon's drawing, but I want to figure it out first for myself before I make a correction.
Oh, I think I know what you're talking about. But
No, it actually does not show up.
No.
Okay.
Well, it might do, but it's just a tiny
Yeah.
bit.
Yeah.
Yeah, and actually, if I just do that, I've done it now.
Right.
Yeah,
Okay.
I just put a little dot there, a little right angle.
Yeah, exactly.
Yeah. But I didn't try to do it, so yeah, it's good that it was right to point it out, even if it doesn't show. Right. I wouldn't have done it.
I don't think it actually shows up. I think it's actually inside here. But let's say, my screen back. If I were to, let's say, move this line in like this, right?
Yeah.
Here, so that this cutout was not as deep, you would need to take this distance here, measure it on the top, right?
Yeah.
And then drop that line down, and then the same this way.
You measure on the side face backwards, wouldn't you?
Mm-hmm.
If that makes sense. I know what I'm talking about.
So you would so this bottom line, you would go one in, or the depth in, this depth, right?
Yeah.
Let's say this is half. You go a half here, and then you would draw that guideline, like this, and then that would give you the whatever.
Yeah.
It's not parallel, but yeah. Okay, so Simon, I know you got to run, so we're not going to get to exploded isometrics. But the idea is when you have multiple pieces, what you're going to wind up doing is, let's say let's say I have two pieces here, and I'm separating them like this. That separation line is now at an angle in an isometric view, right? So you would take your triangle and make a guideline from like a corner of a piece and just run that guideline all the way out, right? And then so then I would start my second piece here. Let's say I had another base, whatever, that. And then the third piece would go here, like that. And so what you can wind up doing is drawing an explosion of different pieces and how they fit together. I think you could probably figure that out on your own. I'm happy to show you later. But basically, you're just taking these lines from the piece and then extending them out, just like we did these projection lines over here in the orthographic view. But we're going to use them, to create alignment within, different orthographic or isometric projections.
So they're like that's like a component shape of the whole that you're projecting through there. Is that the idea?
So the idea is like, here, I'll find one I did by hand. Here's a good one. Right? Okay, so this is a set of control boards, and the lines are not perfect. I guessed this. I didn't use any tools, but so you have this box, and you can explode it in any direction. I could have exploded them this way, but I chose to explode them in the same direction they were going to be assembled. And then I just drew, a line from this point on the corner straight up, right? And that matches, or should match. I'm a little crooked, but it matches where this top face is. And so for like assembly diagrams, that's really important that you can explode things parallel, right? So I took this line and I drew it up. I took this line, drew it up, this line, and then I can use those to draw this entire piece over here. So it's useful for assembly, right? Like I can break out where these bolt symbols go and how the bolts go in, and I can explode things on different axes. So long as I just trace those axes with this triangle, everything is going to line up nice and perpendicular. Another example of that, let's see. Here is like the useful example. So this is like a front standard I was just kind of doodling, but it's laser cut, right? And so there's a lot of pieces. So I could draw it as like a block in something like, this drawing here. But really, like, this is not going to give you too much information about how this part goes together, right? So I draw the camera first, and then take an individual component set, right? Like the front frame within the front standard, break that out, and then do a exploded isometric where, again, very wiggly, but, this corner lines up with this corner, with this corner, and this corner, and I just draw them in space apart so I can see how everything links up, right? And then this guy was exploded out in this direction, and this guy was exploded out in this direction. But it's really just about creating guidelines or mental guidelines of, which direction things are moved in, and then keeping all of the parallel lines on your 30 degrees and 120 degree axes.
Yeah. So the point of this is that it helps you create you can visualize more quickly this way. Is that the
Yeah,
reason why you do this, and then you then take it to CAD?
right. So in CAD, like if this were the piece that I were making, there's no need for me to draw it, right? I could just make this in CAD.
Yeah,
like it's easy. But I have, for example, go back to this camera, right? I have made this camera, a prototype of it that's medium working, that I will get back to when I get back to the laser cutter. But this took me a very long time to do because I started in CAD. This was years ago. And what I did was, like, I drew all of the planes and I stacked them up, but I did all of the extrusions, and then I started making cuts where the finger joints would, align, right? And so the number of steps, like if you're in Fusion, right, you're not like really counting objects, you're counting the number of steps to create a part. It was huge, right? There were way too many operations because I had not pre-visualized how things fit together. And so making a drawing, go back to this one, where, even if I don't dimension it, right, I can figure that out later, or I could do that here. But just figuring out, like, how many pieces need to go in, how those pieces will interlock, which of these sides of which of the pieces have a tab on it, and then which of these have cutouts, will allow me to draw this thing in CAD in 5 steps instead of 20.
Yeah.
And just like trying to figure things out, like as I'm thinking about it, it's way faster for me to do it by hand, and then model it in CAD, but figure it out on a piece of paper, right? Like this, I started by just drawing squares, and then I started adding tabs and erasing and adding cutouts to match the tabs. And it's just, I think it will be a much faster process. So, like, I learned to hand draft first, and then I went to computer drafting, and I have not really hand drafted anything, as you can tell, in a very long time. But as my designs became more and more complex, they just started taking a ridiculous amount of time in CAD, where, if I took a day, drew a camera, and then drew all of the component pieces and drew all of the interlocks and then exploded them, spent a day on paper, then, a 3-week CAD project might turn into a 1-day CAD project.
Yeah. 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 I've got this, was it this time last? No, it wasn't this time last year, but so probably around about 8-9 months ago, I decided to design a large format camera, which is shelved at this moment. But I couldn't. It was also at a time when I didn't really know that much about how to use CAD, let alone anything else. And I found it easier to actually just start to draw the thing out,
yes,
to see it in paper before I could actually work out how on earth do I make this go onto a computer. So that definitely helped me. I mean, the drawing was ridiculously simple, but I didn't really get it until I actually got it down on paper, what I was actually trying to achieve, and be able to translate it onto CAD. But I've not been back to paper since starting off.
I really haven't been using paper for a very long time. Swap my video. So, like, the first camera dactyl that I made entirely in CAD, and it took me like 3 months. All I was doing, I was just like fiddling around. I had just bought a printer, and it was useful in CAD because I didn't really know much about tolerances and fit. And so each piece that I made, I could then just test a test block and print it off on my printer. But, kind of now that I know the tolerances of things and how they fit together, I almost always start with a sketch of what the camera looks like on paper. But the ability, and this is where the tools come in, is to break that camera into component parts and then draw those interacting parts and sort of how gears mesh or how things are assembled. Really, like, any CAD designer, I think, professional or not, probably would hand draw first.
Yeah, I can see a benefit, and I've not understood how to do what we've done today.
Right, and that's why I wanted to do it. Like, it took us an hour. I probably could have been smarter and done it in 15 minutes, but like, now that you can use the T-square and the angle, like for drawings of, a sketch of a camera, like, this one, you don't need a T-square and a triangle, but you have the same principles, right? And if the camera's a little wiggly, so what? You dimension it, and then it's not wiggly in CAD.
Yeah.
But it's nice to break out the T-square and the triangles once you're trying to draw the little mechanisms and things that really stop making sense if the parallelicity goes away.
Along with the Englishnicity.
Yeah. Yeah.
Yeah, I mean, as I've mentioned in the chat here, I do have access to a drafting board.
Yeah.
And it's great to use when you've just got that rule that goes up and down that's parallel, and you can just drop things onto it.
And so, like, it's not my goal to be or to make you guys into like excellent hand draftsmen, but you should absolutely play with that. It's really fun, but like just the ability to like think about it and work things out on paper, like even in a notebook with squiggly lines. It's way easier if you get like what the 30, 60, 90 triangle is about, and how you take a square and rotate it to the side.
Yeah. No, that's good. Right, and with that, I must leave you. So
okay, it's good to see you. Send me some drawings if you make some.
Yeah, absolutely, and nice to see you, Graham, as well.
Yeah. It's been a pleasure, and Ethan, thank you very much.
Yeah, you're welcome.